Today we're talking about problem solving with trig. We're going to first kind of talk about angle of depression, angle of elevation. So an angle of depression is the angle formed by a horizontal line and the line of sight to an object that is below that horizontal line. And so if I'm looking at the diagram, they have these horizontal lines drawn. So that's like if this person standing at the top of this building was looking straight, that horizontal line would represent that. Same thing here, same thing with the person on the ground. And so the angle of depression is when they're looking downward. So the straight line above the first or below the first horizontal would be an angle of depression. So angle 1 is an angle of depression. I can see a similar thing with angle 3, right? They're looking down for angle 3. So those two are what I would call angles of depression versus an angle of elevation is when they're looking above that horizontal line. Okay, so we can still think of the same horizontal lines. This person is looking, if they're looking up at the person at the top of the restaurant, that would be an angle of elevation at angle 2. And then the person on the ground, if they're looking up at the person at the observation deck, they're looking upwards, that would be an angle of elevation at angle 4. And so what we can see is that we have all of these horizontal lines are actually parallel to each other. So since the horizontals are parallel, we know then that these are alternate interior angles. And so alternate interior angles are congruent. And so angle 1 and angle 2 are congruent because they are alternate interior angles. I crossed my L and my T. So in problems, sometimes we'll be given like an angle of depression when we really need the angle of elevation that's opposite it. And so that will help us find the value that's needed. So for example, like in example 2b, we can see that this 23 is an angle of depression, but the triangle is not related to that value, right? So if I can see a triangle in the diagram here, and so that means that I'm going to need to find the corresponding angle of elevation, the 23-degree angle there, and use that. So it's giving me a piece that's related to my diagram, but not necessarily exactly in my diagram. And so since I've annotated that, let's just look at this. So Nadim sees the tour bus from the top of the tower. To the nearest foot, how far is the bus from the base of the tower? So they know that the tower is 180 feet. They know that angle of depression that Nadim is looking at the tour bus is 23 degrees, which means that the angle of elevation from the bus to the top of the tower is also 23 degrees. So they want to know how far is the bus from the tower. So they want us to find the length of this side. Again, we're under the assumption that the tower is perpendicular to the ground. So we're creating a right triangle there. So if I think about labeling my triangle based on that angle of elevation, my hypotenuse would be the dotted line, right? The imaginary line of sight. My adjacent side would be the side that I'm looking for. And then the opposite side is the height of the tower. So if I think about that and SOHCAHTOA, I want to know A and I know O. So that means that I'm going to use TOA to set up my problem, right? Because I know that O is 180 and I want to find A. And so what that means is that we're going to set up tangent of 23 tangent of 23 would be equal to my opposite side, which is the 180 feet, divided by my adjacent side, which is my unknown. So my unknown is x. I'm looking for tangent of 23 equals 180 over x. So when I cross multiply, this is the one where I'm going to have a couple steps to solve, because when I multiply this, my x is over here. So I've got x tangent of 23 equals 1 times 180. Okay, so when I do that, I'm cross multiplying. So this gives me this, and that is from there. So that means that in order to solve for x, I would have to divide both sides by tangent of 23. So when I'm finding x in my calculator, I'm going to type in 180 divided by tangent of 23. So from here, I'm doing 180 divided by tan 23. And that gives me 424.05. And we're typically rounding to that nearest tenth. So we're going to make that 424.1. So it's about 424 feet away. So I included both rounding to the nearest tenth and rounding to the nearest foot, because I'm not sure, it didn't give us a direction, right? So on the assignment, it'll tell you. So if it told me nearest tenth, I would use the 424.1. Okay, so in the previous problem there, we have a little bit more complicated of a situation. So we have a reverse bungee ride. Reagan stands halfway between two vertical posts. Two bungee cords extend from the top of the post to Reagan's waist with a height 1 meter above the ground. How tall are the vertical posts? So in the diagram, I'm going to zoom in a little bit. We can see that the posts don't necessarily look perpendicular to the ground, but that's where we're assuming, right? We're assuming that these are straight, that this is our right angle in our diagram. And so we're given a 70-degree angle, and we're told that Reagan is halfway between. So that means that we've got 4 meters on this side and 4 meters on this side, because that's half of 8 meters, right? So it's split in half. So we want to just think about one of these triangles, because they are exactly the same, right? Look, they're the same height. They're the same angle. Oh, I highlighted the wrong one because they're giving us x over here. Let's fix that. And so then our right angle would be there. And so I can see then that my height is the side opposite that 70 degrees, right? So my angle is labeled here. So I want to label my triangle based on that angle. So my hypotenuse is the bungee cord. The adjacent side is that horizontal distance, and the opposite side is x. Okay, so notice that when we're doing this, everything in the triangle is a meter above the ground. So when I'm finding the height of the posts, I'm actually going to add 1 meter. So I would say that the post is going to equal x plus 1 meter. Okay, so I'm going to have to add 1 to the end of my solution. So this one, I also want to use tangent, because in this case, I know A, and I want O. So in the same way that I had to use tangent because I knew O and wanted A in the last one, I'm going to use tangent again. Okay, so that means I'm going to use TOA for this problem as well. What you'll notice though is that my variable will be in a different spot. So it's the quicker way to solve because x is in the numerator. Okay, so let's set up. So we've got tangent of our angle, which is 70. So tangent of 70 degrees is equal to opposite x over adjacent 4. And so this one, when I cross multiply, if I put this over 1, that'll give me x. So x is equal to, and then this will give me 4 tangent 70. And so we'll plug that into our calculator. So 4 tan 70 is 10.98. That 8's going to round that 9 up to a 0, which means we really have 11.0. So x is approximately 11.0 feet. And so if I plug that in, that means that the post is 12 feet tall. So because we had that 1 meter that our triangle was drawn at above the ground, we had to add that 1 meter to our answer of 11. Oh, I wrote feet. Sorry, meters. Of 11 meters tall. Oops. Okay, so then we've got an example. We're actually going to skip this one. Okay, so for this one, you can write that we're going to skip that example. There are no homework problems that go along with it. We are only going to apply with right triangles, so I don't want to have to do something that we need to use law of sines or law of cosines with, but we are going to use those things here. So for this example 4, we're going to use it to develop a formula that we can use to solve the problems in B and C. And so this is going to go back to when we derived the law of sines formula. So remember that when we derived the law of sines formula, we drew this altitude in the triangle. So if I draw this altitude again, that's going to represent the height of the triangle, because we know that the area of a triangle is equal to 1/2 the base times the height. I'm going to write that in words. 1/2 base times height. So in this triangle, they've labeled the base as B, and then we just created this height H. And so the problem here lies in that I know then that it's 1/2 whatever the length of B is, but I have no idea what H is. So what I can do about H, though, is I can write it in terms of an angle. So if I think about this triangle over here, I can think about angle A, and I know that H would be the side opposite, that C would be my hypotenuse, and that this little unknown piece, right, I don't know what this is, part of B would be the adjacent side. So the two that I have variables for are O and H. So remember, with law of sines, we wrote like an equation for that height. We called it X though. So if I use sine of A, so sine of that angle A would be equal to H over C. And so I can figure out what H is, what the height is, what I don't know, if I solve that equation. So if I want to think about H as my unknown, if I want to solve for H, if I put sine of A over 1 and I cross multiply, that's going to tell me that H is going to be equal to C times sine of A. And in the triangle, I should know what A is. I should know what C is. Those are parts of the actual triangle. And so I can use that in place of H. So if H is C times sine of A, then that means that I can think about this formula as being 1/2. We already had the B, but now times C sine A. One thing to note is that I could do this with C. And if I did that with C, we would get that H equals A times sine of C. Okay, so there's actually going to end up being 3 different formulas for the area of a triangle if I don't know the height. Okay, so the first one is what we just found. It's the area would equal 1/2 BC sine of A. We could also use 1/2 AC sine of B, or 1/2 AB sine of C. So depending on which angle and sides I know, as long as I know an angle and the 2 sides next to it, so not the side across from it, I can use that to find the area of the triangle. Okay, so I'm finding the height using one of those pieces. Okay, so let's look at this in a problem. So they've changed the letters on us because they like to do that. So what I can look at is that I know angle E. So I know that I'm going to have sine of E, which means that I would need to know the other 2 letters in the triangle sides. So if I use the E, that means I need to know F and I need to know G. So it looks like that's what they gave us. So they gave us that G is 3. So this side over here is 3. And they gave us that F is 4, and this is in centimeters. And so that means that we're going to end up with centimeters squared as our area unit, right? So if I multiply 3 centimeters times 4 centimeters, that means that my units are going to end up as centimeters squared, because centimeter times centimeter makes centimeters squared. My angle E is 116 degrees. So I'm going to type that in the calculator, but without the centimeters. So that means that we're going to do 1/2 of our sorry, I forgot already. 1/2 of 4 times 3 times sine of 116. And then that gives us 5.39. And so that means that that would be our area. So about 5.4 centimeters would be our area. So 5.4 square centimeters would be the area of that triangle. Okay, so for our last one, they have given us 3 sides of a triangle. And so we need to know 2 sides and an angle. And so in order to solve this, we need to solve for one of the angles. In order to use our area formula. If we think about this, if I'm given 3 sides, that means I'm going to use law of cosines. And so it doesn't matter which angle I solve for. I'm always just going to pick the biggest angle. So if side DF would be side lowercase d, or sorry, side lowercase e, because that's the letter we don't have there. Side DE would be lowercase f, and then side EF would be lowercase d. I'm just always going to pick the largest angle. So that means that I want to find cosine of E and use the law of cosine. So remember that the law of cosines tells us that cosine of E would be d squared plus f squared minus e squared all over 2 times d times f. So that means that the measure of angle E would be inverse cosine of those things. Okay, so let's plug in this step. So if I plug in D is 14 squared plus F is 13 squared minus E is 15 squared, and I'm putting that all over 2 times the 14 and then times the 13, that's going to give me the measure of angle E. Once I know the measure of angle E, the area then would be 1/2 the other two letters multiplied together. So D times F times sine of whatever E is. Okay, so by doing this, by solving for one of the letters, right, I'm going to use the other two sides in that area formula. Okay, so let's plug this into our calculators. So we have inverse cosine of our 14 squared plus 13 squared minus 15 squared all over 2 times 13, 14. It doesn't matter really, but let's be consistent. And so that gives me an angle measure of about, we'll say 67.4 degrees. Okay, so I'm going to say that that angle is 67.4 degrees. And so because I'm rounding here and then here, I could end up with different answers depending on which angle I find. So my suggestion is just always find the largest one. That way you're kind of consistent with how you do the problem. So remember that D was our 14, F was 13, and then we're going to do sine of the angle we just found, which is 67.4 degrees. Okay, so we're going to type all that into our calculator. So 1/2 14, 13, and then sine of 67.4 is what we used. So that's about 84.0 units. For that area. So watch what could happen. So if I, instead of using the 67.4, if I hit this answer button instead, see how it gives me exactly 84? So we can see that the rounding is kind of changing things because of those values. So just be careful with what you're doing. On like a test, this kind of question would be multiple choice. So you'd be looking for the closest answer. So this one, there is a little bit of wiggle room just depending on how you're rounding. So I would keep to rounding to 1 decimal place because that's how I calculated the answers on the assignment. Okay, so we kind of did a lot. We're just practicing more with SOHCAHTOA and then also using this area formula. So we won't have to do any derivation again. We did that just so we could use the formula. So your assignment will just have one problems like B or C where you're just using the formula now.